today what we're going to be doing is looking at one more rewriting of a logarithm, and then we're going to start evaluating some of these, as well as using the properties to evaluate given values for the logarithms. So if we take a look at 13, you'll notice it's a division. So what we're going to do is we're going to separate that with subtraction. And then what we'll do is we'll take a look at this first term right here. And we'll notice that the 8 and the r are joined together with multiplication. So we're going to, again, split that up. So log of base q to the 8 plus log q of r squared minus log q m minus 1. Again, I'm not going to split up this last term right here because it's m minus 1, and because it's minus, that's actually not a property to split. So that's going to remain the same. The only other thing that I'm going to do is that this 2 out in front, I am going to, or I'm sorry, 2 is the exponent. I'm going to send that out in front. And then that will be my answer. Now, if any of these questions that we start doing, you don't have in the packet, just write it on the back of the sheet. There should be room on the very last page. So just continue on with that. So this one right here, I'm going to start evaluating. I see this exponent right here, and I'm going to move that to the front. So 5 times log base 10 of 10. And what we talked about before is that when the base is the same as that number, that evaluates down to 1. So 5 times 1 equals 5. If I take a look at number 15, again, I'm going to look at the numbers. I have a base of 2, and then I have that number 8. What I'm going to do with that number 8 is I'm going to rewrite it. I'm going to rewrite that as 2 to the third power. Now, this happens to have the same base. If it didn't have the same base, one thing that I could do is just expand it by saying 2 times 2 times 2, and then see where that leads me. The 3, again, will become a multiplier out in front. And then I will have 3 times 1 because that evaluates down to 1. So my answer is 3. Number 16 looks a little bit more complicated, but still very similar. What I'm going to do is I'm trying to evaluate, see what it equals. So I'm going to set this equal to x because we're trying to figure out some unknown number. And right now it's actually written as a logarithm. I'm sorry, as an exponent. And I'm going to write this as a logarithm. So if I rewrite this as a logarithm, it's log base 5 of x equals log base 5 of 9. Again, that 5 was the base, so it went here. The x went here, and the exponent went there. So I rearranged it. Now if we look at what we have, notice how the logarithms and the base are the same. And so x would equal 9. So this evaluates down to 9. But hopefully you kind of saw this, just like what we have here or here. 5 to the log base of 5 really just evaluates down to 1. And with this being an exponent, it becomes the multiplier. So 9 times 1 gives me 9. So what was really common a while back, because they didn't have all these tools in their calculators to have different bases, they would have lots of charts. And you go into the charts or in the back of your book. Usually that's where it was found, in the front of the book. And they would have some value approximations for each of these. So log base 2 of 5 equals 2.319. And if you think about what that means, is it really means 2 to the approximately 2.319 0.3219 equals 5. So it gives you these approximations. So they would use these approximations and the properties of logarithms to solve different numbers. Because you can see we have log base 2 of 25, but we only have up to certain numbers. We had 3 and 5. So some of those weird numbers they didn't have a specific number for. So again, they use the properties. And that's what we're going to do. I'm going to take log base 2, change 25 into 5 squared. The 2 is an exponent, so I'm going to bring that on front. So it's 2 times log base 2 of 5. And if you look up here, log base 2 of 5 is equivalent to 2.3219. So I'm simply going to replace that. And I replace everything including the logarithm. And then I will multiply 2 times that number, and we end up getting 4.6438. I'll do the same thing with number 18. I'm going to take my properties and split those apart. So it's going to be log base 2 of 5 minus log base 2 of 3. And now each of these can be substituted. Log base 2 of 5 is at 2.3219. And this one right here is this value. So I'm going to just substitute that in. 2.3219 minus 1.5850, and that gives you 0.7369. Go ahead, pause the video, and see what you come up with for number 19. So what happened is I changed 75 into 3 times 5 to the second, because 3 times 25 gives you 75. 5 squared is 25. And then you can see I separated with addition, and then I also brought the exponent out in front as a multiplier. And that's what you end up getting. And to wrap up today's lesson, what we're going to do is we're just going to use our properties of logarithms to see if the left side of the equation equals the right and state whether it's true or false. So I'm going to rewrite this first one as log base 6 of 6 to the second minus log base 6 to 6. And then I'll have log base 6. And I'm going to change 30 into 5 times 6. Remember, this is going to become 1. That's a multiplier, so this evaluates down to 2. Log base 6 of 6 becomes a 1, so that equals 1. I'm going to do that over. I'm going to separate these on the right side with addition. I cannot simplify this first term on the right side, but I can the second. And you can see these are not true, so this would be false. Go ahead and pause the video again and do work on 21 and see if you come up with what I have at the end. On the left side, I'm going to work with the parentheses first. Log base 2 is 16. 16 changes into 2 to the 4th. Because these both are the same numbers, that's going to be 1, so that's going to reduce down to 4 with the exponent. Log base 4 of 4 reduces down to 1. On the right side, now, even though this says division right here, it's not the one full logarithm, so these are separate ones. Log base 6 of 6 is 1. Log base 6 of 36, I change into 6 squared. So that's going to evaluate down to 2, so I get 1/2. So that would be false.